How does concrete harden underwater instead of just washing away? But what engineers discovered 50 years later changed everything forever. Concrete does not dry out, it undergoes a chemical transformation. Water molecules react with cement powder to create strong crystals. Roman concrete actually gets stronger while submerged in salty water. Volcanic ash creates a rare mineral that reseals tiny cracks. Modern engineers now mimic this ancient recipe for offshore foundations. That mystery discovery was the self-healing ability of these minerals. This chemistry keeps our bridges and dams standing for centuries. That detail becomes important later. Water molecules force cement particles to rebond into rigid crystals. Concrete hardening is actually a chemical reaction called hydration, not drying. Calcium silicate hydrates grow like tiny needles, interlocking for strength. But wait, doesn't salt destroy concrete? Here is the truth. The concrete creates a protective film, blocking salt from steel. Dense mixtures prevent water from reaching the inner metal core. Engineers use heavy pipes to pour concrete beneath the waves. The concrete displaces water because it is much heavier overall. It is basically just creating artificial rock inside the ocean. That detail becomes important later. Water molecules immediately attack the dry cement particles upon contact. This isn't drying out, it is a complex chemical transformation. Calcium silicate hydrate gel forms the structural backbone of concrete. Special additives prevent the mixture from washing away before hardening. Surprisingly, the concrete actually gets quite hot while setting underwater. Needle-like crystals grow and interlock to create immense strength. The gel fills every tiny pore, making the mass impenetrable. But how does it survive the crushing pressure of depths? The material becomes harder over time, even in deep water. That detail becomes important later. High-pressure deep underwater forces water into every microscopic crack. Ordinary cement would dissolve, but hydraulic cement craves this water. Water molecules trigger a reaction, creating strong calcium silicate crystals. Air is unnecessary because the water is part of chemistry. Surprisingly, this hardening process releases heat even in freezing water. Needle-like crystals grow and lock together to form solid rock. The mix stays thick enough to avoid being washed away. It becomes denser than stone, perfectly sealed against the sea. But what keeps it from cracking under years of salt? Underwater, water isn't the enemy. It's the essential chemical ingredient. Tiny crystals grow like needles, interlocking to create a mesh. This hydration reaction happens perfectly even without any exposure air. Deep ocean pressure actually helps pack these dense structures tighter. Most people think concrete dries out, but it actually hydrates. The mineral matrix continues to mature for decades underwater. It is basically like growing an artificial rock from scratch. These underwater bonds hold up the massive weight of cities. Next, we see how this material handles the harshest environments. Water molecules force their way into the dry cement powder. Calcium silicates react with water to form needle-like crystal structures. These tiny crystals interlock to create a rigid, permanent matrix. Unlike glue, concrete needs water to reach its maximum strength. Ocean pressure actually compacts the mixture, making it even stronger. Hit the subscribe button and press the bell icon to get updates. Engineers add special minerals to keep the steel from rusting. The concrete eventually becomes a solid rock beneath the sea. It is essentially creating man-made stone right where we need. Underwater concrete uses specific additives to trigger a rapid reaction. Calcium silicate hydrates grow needle-like crystals to lock everything together. Special anti-washout agents prevent the cement from drifting away instantly. These polymers create a thick paste that clings to surfaces. Surprisingly, concrete actually needs water to reach its maximum hardness. High density prevents salt water from corroding the internal steel. The chemical bond remains stable despite the constant ocean pressure. Months underwater actually make the concrete stronger than on land. It is an engineering marvel hidden right beneath our feet. Extreme macro view shows water molecules invading dry cement powder. Calcium silicates react with water to form strong crystal needles. Special additives create a gel that traps the hardening mixture. Deep ocean pressure actually helps pack these crystals tighter together. Standard house concrete would simply dissolve into a muddy mess. Engineers add specific minerals to resist saltwater chemical attacks. Underwater concrete actually gains more strength over many long years. We transform liquid slurry into permanent rock beneath the ocean. The facts remain, and the search for truth continues.